Hello, my name is Andres Strulovic,
And my name is Sofia Blasini.
and we will guide you through a double displacement chemical reaction and its equation. In this video, we will demonstrate and explain the process of a double displacement reaction using sodium hydroxide and nickel 2 chloride solutions as reagents, which are substances that interact together, shown in the left side of the equation, in order to obtain sodium chloride and nickel hydroxide as products, which are the new substances formed as a result of the interaction shown in the right side of the equation. The arrow that separates the reagents from the products indicates that a reaction has taken place in the direction of the arrow. First, we must check to see if the equation is balanced, or if there is the same amount of atoms for each element presented in the reaction. Sodium ions have charge 1+, hydroxide 1-, nickel 2+, since it has Roman numeral 2 that indicates its charge, and chloride 1-. The equation is balanced because the molecules have a net charge of 0. After the virtual experiment, we will discuss more what happened during the demonstration and why this is a double displacement reaction. To begin, we need two 50 milliliter beakers that we obtained from the Containers tab. To have a more visual representation of each compound, we label the beakers by double-clicking on them and writing the compound name. We start by labeling sodium hydroxide on one empty beaker and nickel 2 chloride on the remaining beaker. Now, from the Materials tab, we obtain 1 molar sodium hydroxide and pour 15 milliliters into the beaker that we labeled as sodium hydroxide. And then pour 6 milliliters of 1 molar nickel 2 chloride into the beaker, respectively labeled. Note that both of these solutions have a concentration of 1 molar, which corresponds to the ratio of moles of solute to liters of solution. Now, let's observe the two compounds. As we can see, sodium hydroxide is colorless, while nickel 2 chloride is of a color green. We now mix both solutions by pouring all the 6 milliliters of nickel 2 chloride into the beaker containing the 15 milliliters of sodium hydroxide. When we zoom in on the beaker with the final products, we observe that the result of mixing sodium hydroxide and nickel 2 chloride is a colorless aqueous solution and a green solid precipitate. To safely clear the workbench and clean up our lab, we throw away the beakers and its contents into the waste recycle bin on the bottom of the screen.
When observing the chemical equation for the reaction of sodium hydroxide and nickel 2 chloride, we can recognize that the resulting aqueous solution is sodium chloride and the precipitate is nickel 2 hydroxide. We had already identified the phases of the reagents and products using the parenthesized subscript in each compound before we performed the experiment, stating that sodium hydroxide, nickel 2 chloride, and sodium chloride are aqueous and that nickel 2 hydroxide is a solid. We know this because when we refer to the solubility rules, we find that hydroxides are insoluble and therefore do not dissolve completely in the reaction, thus resulting in a solid, and nickel 2 hydroxide is not an exception to this rule. Now, why can this be considered a double displacement reaction? By definition, a double displacement reaction is a reaction in which the cations, which are the positive charged ions, and anions, which are the negatively charged ions, swap atoms to form new substances. This equation shows that these were indeed swapped in the products. The three different types of double displacement reactions are precipitation reactions, gas-forming reactions, and neutralization reactions. In this lab, we focused on precipitation-forming double displacement reactions and demonstrated how we can predict reactions by establishing a balanced equation of the reaction, always using the solubility rules as a guide to identify the compound's phases.